Time for part 2 of the awesome Mark II balsa wood glider with my dad. And this is the very last Spark Extra, because Spark is headed back face to face this coming week. Look forward to seeing you there.
The things that I'll need to make the aeroplane, obviously, or the glider, are obviously in balsa wood. So that will be the material that I use to make it. I've shown you the sanding block before. I have a little saw that I'm going to use at a particular point in making of the wing. I'll be using a craft knife, craft blade. If you're using one of these, be very careful, they're very sharp. I'm actually going to use super glue. If you're looking about using that, you'll need to have a long talk to your parents. This stuff you've got to use very, very carefully. I have just a piece of sandpaper as well, which will be used in one particular spot in making of the wing. I then have my instructions there, well, not so much instructions, the dimensions. Finally, I'll need some weight on the nose to balance the aircraft from a weight and balance point of view. The wing is going to be 50 centimetres wide in the wingspan. It's going to have a mean chord, that means an average chord of 50, so it's going to be 60 at the root and 40 at the tip. All right, we bring out the knife and we do our first cut. Finally, we've got it out. So that's the leading edge of the wing at the front there, and that's the trailing edge of the wing. Okay, so that's where the thickest part of the wing will be at 25%, and then tapering down at the back. All right, I'm going to use the coarser one on the back, and I'm going to keep it all flat. Use a block because it's the stiffness that helps to control the amount of material that you take off evenly. Actually, I think I'll stop. Don't want to get that too thin because if it hits something, when it crashes or whatever, that could be rather damaging. Now, doing the leading edge is a little bit more finicky. So, how do we do this? We'll just go along like so to start with. Yep. And we'll flip the thing over, and we'll do a bit on the other side, just around. I'm not going to touch any of this part at the back, but just the along the leading edge. We've got a rounded edge. So I think that side of the wing is looking pretty good. Now we just need to work on the other side. Well, I think that's looking pretty good. Just going to do one more little thing just to improve with the form drag. That's the smoothness with which it flies through the air, or the air flows around it. I'm going to take a little bit of material off the corners. And once again, we look to smooth things off. All right, so I think that wing at this stage is about finished. The fuselage is going to be 30 centimetres long, plus I'm going to put a centimetre on the end so that if I do try and use a rubber band to launch this thing, I've got something to hang on to right at the back of the aeroplane. So we want two strips of balsa wood, 30 centimetres long, and the maximum height of this is going to be 12 millimetres. Right, right, 12. So we have two strips of balsa wood, 31 centimetres long and 12 millimetres high. And we're going to have to stick those together. And with super glue, once it goes down, you don't want to move it. It's down and it's done. I need to stop the work on the fuselage for a moment and go back to the wing. And I'm going to cut part-way through the thickness of the wing. And then I'm going to break the wing upwards and glue. And so what I've got is a line at the center line of the wing, right down the middle, and I'm going to put the saw right on that and start cutting. But I'm not going to cut all the way through. I'm only going to cut part way. Now I'm just going to get this piece of sandpaper and just send it down that cut just to get rid of some of the furry bits of balsa wood that are in there. It's that side and this side of the cut. These bits of plastic, they're called window packers. That's 10 millimeters. When I crack that, just crack the wood a little bit and that drops down onto the tabletop, then I will have 3 degrees of dihedral on either side. Ruler up underneath. That's good idea. And a ruler down on top. And that way I've got a capsule. Right, here we go. Yes, I can hear the fibres breaking. Okay, we've cracked it. And we're just going to put some super glue. We are going to put extra on this one because it's got to get down inside. I'm having a fail here. My cut in there is too big. Oh well, we're going to have a little bit more dihedral. That's what happens when you're doing something for the very first time. That will be, that's about 3 degrees of dihedral on either side. I'm going to install my wings so that the wing will have some angle of attack compared to the fuselage. And I want to do 3 degrees of angle of attack. 10 centimeters is where the wing will go. Okay, 10 centimeters is 100 millimeters. And then the wing is 60 millimeters wide or chord. To get a 3 degrees angle of attack, I need to cut in over 60 millimeters by 3.1 millimeters. We'll say 3 millimeters. Okay, there we go. We've got the little slot where the wing will be attached. Well, that is where the wing will connect on. I'm not going to touch it because it's still got wet glue on there. So you can begin to see the size of the aeroplane, and then we'll have the tailplane on here. Okay, what I'm actually going to do with this now is to reduce the size of this and therefore reduce some of the weight. pretty good. And now, also, for all the smoothing off, we're going to just round things off. It's all part of that streamlining. Okay, I think we can say that our fuselage has been made. The horizontal stabiliser. It's got a chord of 3 centimetres and it has got a span of 16.6. Here we go. So that's our horizontal stabiliser. I'm not going to be as worried about the aerodynamics of this aerofoil because the loads that it's got to generate are much smaller, but we will certainly round off the edges and taper it at the back. But we'll tend to do a little bit on both sides of the aerofoil. I'll just trim a little bit off the wingtip there. There. Looks very good, in fact. Okay, so there's our horizontal stabiliser. The vertical stabiliser, where it's going to be a chord of 4 centimetres and a height of 6.25 centimetres. Okay, I'll get the knife. Right, there's our vertical stabiliser. Anyway, we'll see how it all behaves. Well, there we go. Take the plunge. Oh, that's not too bad. It's dropping down a little bit on that side. Not too much. Oh well, not quite sure how that will behave when it flies. It's a little bit of concern, that. Anyway, that's the fun of making a model aeroplane. Hopefully those bonds will all hold together. Okay, here we go. Well, our tail fin is on. Vertical stabiliser. So we have something that's beginning to look like an aeroplane. But will it fly? We now need to do a balance, a weight and balance. And what I've done is I've got a piece of timber, a little bit of aluminium scrap angle I had, and I've screwed those onto a block of wood. And I'm going to put those there and there. Somewhere around about 25% or quarter chord to a third chord. If I get the aircraft with weight on the nose there and get it balanced, that should be pretty good when I try and fly it. One lump. No, nothing happened. 2 lumps. Not quite. A little bit more. Ooh, there we go. So yeah, I'm about a third, maybe a bit over a third. Ladies and gentlemen, here we go with the very first flight. Whoop, I'd say the nose is still a bit too heavy. I'll pull a little bit of that putty off. Okay, flight number 2. Whoa, that looked pretty good. That was beginning, the aeroplane was beginning to pull up, which is exactly what I would want it to do. It's time to pack up and go for a drive. We are at Norwest Anglican Church. We are about to see whether this will fly or glide like a brick. Full flight number 1. It'll be just a gentle, smooth throw. Whoa! Well, it flew. Flight number 2. Well, it's flying. I'll try throwing it just a little bit harder and see what happens. Whoa! Okay, not very good at pulling out of a nosedive. That is making me wonder whether or not horizontal stabilizer hasn't got enough power so that when it's up and coming back down like so, that needs to be pulling down on the back of the aircraft and pulling it through. I've made up an improvised elevator. An elevator is the control surface that goes on the back of the horizontal stabilizer. It's just cranked up at a slight angle, so it should give a little bit more downforce, and also it increases the area of the horizontal stabilizer. Yeah, well, the sort of things I'm seeing about that aircraft now is that the dihedral and the like is working because it's not just breaking off left or right. That time it slowed down, wobbled a little bit, but then brought it back to stable. So that's working. It's reasonable. If you made that aeroplane again, possibly change the angle of incidence of the main plane, probably increase the size of the horizontal stabilizer. They're the sort of things that would come to mind. I have just made another little modification to the aircraft. As you can see, I've cut a notch in there. So let's just see what happens when we launch it with an elastic band. Okay, launching with elastic band. Well, that was impressive. Maybe not. And well, maybe with a little bit more practice, I could actually do a loop-the-loop. Well, we've had our first structural failure. Where I cut the fuselage to put in the notch, it didn't like the crash landing just then. So I think we'll call it a day. It's been good fun having an experiment, and this will be worth playing around with more. Whether I do, I don't know. But have a good day. Bye-bye.